Math Blast 5, Understanding Multiplication. Here I have an array, and I'm looking at making a statement here in terms of equal groups. So when I have an array, the rows represent my groups. In this case, I have 3 rows, or 3 equal groups. And there are 4 items in each of those groups. So 3 equal groups of 4 is, we can skip count, 4, 8, 12. 3 equal groups of 4 is 12, so 3 times 4 equals 12. Here I have another array, and this time I have 2 rows, so I have 2 equal groups. And there are 3 items in each of those groups. So I have 3, 6. 2 equal groups of 3 is 6, so 2 times 3 equals 6. Distributive property. Show an array for 4 times 3 equals 12, using the distributive property. Well, I know if I have an array for 4 times 3, then I have 4 rows. And I'm going to have 3 items in each of those rows. I have 3, 6, 9, 12 total items. It wants me to use the distributive property here. So the distributive property says I can take this whole array or this whole multiplication sentence here, and I can break it into some smaller parts. So here I'm going to just break it right in the middle. And now I have an array that's 2 groups of 3, which I know is 6, and another part to my array, which is 2 groups of 3, and so that is also 6. Now I can represent that using mathematical sentences here as 2 groups of 3 plus another 2 groups of 3 is the same thing as 4 groups of 3. And we determine that 2 groups of 3 is 6 plus another 2 groups of 3 is 6. And so that should be equal to what 4 times 3 is. And 6 plus 6 is 12. So we can determine that 4 times 3 is equal to 12. Addition. Add 72 plus 11. Here I'm going to add my 1s to my 1s, which gives me 3 1s, and my 10s to my 10s, which gives me 8 10s. So 72 plus 11 is 83. In this case, I have 142 plus 69. I'm going to rewrite this problem in a vertical form. 142 plus 69. Notice I'm writing my 6 in my 10s place and my 9 under my 1s place here. Because when I'm adding, I want to add place value to place value. So I have 2 1s and 9 1s. That's 11 1s. I can't write 2 digits in one place value here though, so I'm going to leave one of my 1s here, and the other 10 1s will bundle and make a group of 10. 6 10s, 4 10s, and 1 10 is 11 10s. I'm going to leave one of my 10s as 10s, and 10 of those 10s will bundle and make 100. And 100 and 100 is 200. So the sum, the answer to the addition problem, 142 plus 69 is 211. Write the rule is what we're looking at in the patterns box here. What rule is the function machine using? So here I'm trying to determine what happens to each of my input numbers to get the corresponding output number. I know that if I take my 2 and I add 8, I can get 10. Or if I take my 2 and I multiply by 5, I can get 10. But what I need to determine is which one of these operations works all the way through the table. Because to be a rule, it needs to work all the way through my function table here. So 4 plus 8 does not give me 20. We're going to eliminate that as the possible rule. But an input of 4 times 5 will give me an output of 20. And an input of 6 times 5 will give me an output of 30. So the rule is input times 5 equals the output number. Partition on a number line. Label the fraction for point A. Here I'm going to look at a fraction, which is created from a numerator and a denominator here. The denominator, let's determine the denominator first. It tells me how many equal parts are in the whole. From 0 to 1 is the whole. So I have 1, 2, 3, 4, 5, 6 equal parts. So our number line is broken into sixths. A is at 1, 2, 3, 4, 5, the fifth of those 6 equal parts. So my numerator will be 5. And the fraction that represents point A is 5/6.